Time is given and the distance is also mentioned in the straight line graph itself, but we have to find out average velocity and average speed. So during the upward motion of the ball, the acceleration is downwards. Acceleration of the ball is said to be negative of acceleration. Velocity is nothing but displacement by time taken. So displacement is shortest distance traveled. So it is the distance from initial to final. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 5 of chapter 3. And here in this session, it is all about the numericals, whatever you study on the basis of chapter 3, that is motion in a straight line. So let us go to our first numericals, that is a car is moving along a straight line, say O, P in the figure. So you have got a figure over here wherein a car is moving along a straight line. In this chapter, we study regarding the rectilinear motion, that is a straight line. So here an object, that is a car, is an object which is moving along a straight line, that is OP in the figure, this O as well as P. It is from R, O, Q as well as P. It moves from O to P in 18 seconds. So from here to here, it is taking 18 seconds. So from O to P, for a car to move from O to P, it is taking 18 seconds now. And returns from P to Q. And again it returns from P to Q. This is the returning time, that is 6 seconds. So it takes 6 seconds to return from P to Q. So what is the average velocity? So you have to find out average velocity and average speed of the car moving. So first question will be from O to P, what is the average velocity and its speed? And the second one, from O to P and back to Q. This is our second question. So first question with respect to average velocity and average speed. That is the first question, from O to P, what is the average velocity? What is the average speed? Again from O to P and back to Q, the complete one, that from O to P and back to Q, you have to find out the average velocity and average speed. So coming to the given terms. Given time is given when it travels from O to P. So time from O to P is equal to 18 seconds. And then from P to Q, your time is 6 seconds. So these are the time is given and the distance is also mentioned in the straight line graph itself, but we have to find out average velocity and average speed. So in order to find out this average velocity of the first one, now average velocity is equal to displacement by time taken. So displacement by time taken. So what is the displacement over here from O to P? So differences is 40, 40, 40, 40. So 40 plus 40 it is 80, 80 plus 40 it is 120. So totally we are taking, it's a displacement. So for the first question from O to P, the displacement, because it is following a straight path. It is not any curved path or something. It's a straight path. So that itself will be the shortest distance. What is the definition for displacement? It is the shortest distance traveled, right? So here, shortest distance or the lengthiest distance, both are one and the same in case of the first question, that is from O to P. O to P. This is a distance as well as this itself is a displacement. There is no other shortcuts because it is following a straight path. So from O to P the value is same. So distance is also same. Displacement is also same in this case. So average velocity, whatever the value you get, it will be the same for the average speed as well. So O to P. O is 40 plus 40, it is 80, 120, 160, 200, 240, 280, 320 and 360. So O to P it is, the displacement is 360 and the time taken to travel from O to P, that is 18 seconds. So it is 18 seconds. So it is, distance will be in meters and time is in seconds. So 18 2s are. So what do you have? Your average velocity is equal to 20 meter per second. So this is your average velocity as well as your average speed. So you're done with your first one, that is from O to P. What is the average velocity and what is the average speed? Both the value is one and the same because the distance and displacement both are one and the same here in this case because it is following a straight path and the point is always from O to P. Okay, so you're clear with the first question. Now coming to the second question. So from O to P and back to Q. So from O to P and back to Q. So here in this case, your distance and displacement both are different because from O to P and P to Q. So it is 0 to 360 plus 120. See here it is 40 difference. So 40 plus 40 plus 40. So it is 120. So 360 plus 120. The total path it covers from O to P and back to Q. That is the distance. So when the distance is mentioned, you will have to calculate its speed. So what is this velocity? Velocity is nothing but displacement by time taken. So what is that displacement? Velocity is nothing but displacement by time taken. So displacement is shortest distance traveled. So it is the distance from initial to final. So in that case, you will be calculating from O to Q because this is your initial position I and this is your final position F. It is only till initial to final. That is in case of your velocity. So for this, you can calculate your average velocity. But on the whole, from O to P to Q, you can calculate your average speed. So now, in order to calculate your average velocity for this, let me go with question number B. Average velocity is equal to displacement by time taken. So, what is the displacement over here? From O to Q is the displacement. So, displacement is 240 divided by what is the time taken from O to Q? It is O to P plus P to Q. The total time, you have to add the total time. That gives you the time taken to travel from O to Q. That is initial to final. From initial we started and we are moving till final position, right? The distance is a shortest distance traveled, but the time taken is added up. So it is 18 plus 6. In order to reach Q, no, you will have to take up your 18 seconds also plus 6 seconds also because it is the total time taken to travel, but the distance is shortest distance. So it will be 240, 18 plus 6. So you have got 240, 18 plus 6 is nothing but 24. So you have got 10 meter per second. That is your average velocity in terms of your second question. That is 10 meter per second. So now you're supposed to calculate the average speed. In order to calculate average speed, you need the distance, not the displacement. Distance means it is the total path length. So the total path taken from O to P and from there P to Q. That is from O to P it is 360. Again 360 plus 40, 40, 40, it is 120. 360 plus 120. So here you have got average speed. Average speed is equal to distance by time taken. So what is your distance? 360 plus 120. It is 480 divided by the total time taken to follow this path. It is the same from initial to final, that is 18 seconds plus 6 seconds. So it is 24, which is equal to 24 ones are 24 twos are 48 and 0. So it is 20 meter per second. So what is your average speed here? It is 20 meter per second. What is your average velocity? It is 10 meter per second. So this is all about the first question, that is a car is moving along a straight line OP in the figure. It moves from O to P in 18 seconds and returns from P to Q in 6 seconds. So what is the average velocity and average speed for these two conditions? So for the first condition, you have taken only average velocity, or you can consider only average speed, because the distance it is taking and the displacement it is taking both are one and the same. So distance is equal to displacement in the case of the first question. So it is one and the same. You can again repeat the same step for average speed, which is equal to distance by time. So distance will be again 360 meter divided by time. Time taken to travel from O to P is just 18 seconds. So you can write it as 18 seconds and you can get the value. So it will be again 20 meter per second. The formula is changed, but the values are one and the same. So I just finished up with the one identification, that is average velocity. Similarly, it will go with the second one, from O to P and back to Q. From O to P, it is taking a complete path. So what is speed? It is distance divided by time taken. So it is a total path covered, that is 360 plus 120, and the total time for this is 18 plus 6. When it comes to average velocity, we are calculating only displacement, that is the shortest path covered. So from initial to final, what is the shortest path covered? Only so much. This is the shortest path. So 0 to 240, that is our value. So I have taken 240, but time taken is a constant one. Time taken doesn't decrease. If you just calculate the shortest path, that is okay, but the time is always the same even if you consider the shortest path. So it is 18 plus 6, it is 24. The time taken is the same. We are considering only the shortest path and not the decreased time interval. It is the same time interval, so it is 24. So this is all about your average velocity and this is about your average speed in the second question. So that is all about this first numericals. Now let us go to the second one, that is a car moving along a straight highway with a speed of 126 km per hour. It is about to stop within a distance of 200 meters. We have to find out the retardation of the car as well as the time, that is how long does it take for the car to stop. As you can see in this image, I have told you in numericals you are supposed to visualize things. Imagine. So here the figure won't be given to you in your exams, only the questions will be given. By reading that question you have to visualize or imagine the image, then you can easily get into how to write out given and how to go on with the numericals. So car is moving along a straight highway. Think this is a highway and a person is riding a car, other person is holding a cell phone and coming. So car is just about to hit the other person, that is person B. So before that he applies a brake. So what happens when you apply a brake? It is a push which is given to the accelerating force, right? So you're pushing a motion which is coming towards you. So you're pushing it backwards. So it will be negative acceleration. So that is termed to be a retardation of the car. And how long does it take to stop the car? So when you apply a brake, a car will stop. It won't stop suddenly as soon as you apply brakes. It will stop only after certain interval of time after the brake is applied. So the given terms are, speed is given of 126 km per hour, that is considered to be a velocity, that is initial velocity, because stopping the car, that is the final velocity, and final velocity is 0 because the car will be in rest state. So given is, here your initial velocity u is equal to 126 km per hour. So 126 km per hour, but the SI unit of distance is meters and time is seconds. So this is not in the SI unit form. So I can just write 1 kilometer is equal to 1000 meters. So 126 kilometer is how much? So it is 126,000 divided by, in terms of hours, it is in seconds. So you can consider 1 minute is equal to 60 seconds. So 60 minute is how much? That is 1 hour is 60 minutes. No, so 60 minutes is how many seconds? So it is 60 into 60, it is 3600 seconds. So cancels and it is 35. So you have got 35 meter per seconds. So your initial velocity is 35 meter per second. So u is equal to 35 meter per second, and it is about to stop within a distance of 200 meters. So distance is calculated as 200 meters. So we have to check out the retardation of the car as well as how long does it take for the car to stop. So car retarding, you have to consider three equations. V is equal to u plus at, which is said to be equation of motion. S is equal to ut plus half at square, and v square is equal to u square plus 2as. These are the three equation of motions, out of which for this sum I am considering my v square is equal to u square plus 2as, because you have got the initial velocity, final velocity as well as acceleration to be found out. S is already there, that is the distance, and rest of the terms is which is left out as acceleration, which you have to find out. So consider the third equation of motion. You are giving it as v square is equal to u square plus 2as, where your v is equal to 0 because the brakes are applied and the car is made to stop. That is the final velocity, which is 0. So substitute 0 is equal to 35 the whole square plus 2 into a into s is 200. So a is equal to 35 the whole square, it is 1225, that is minus 1225 divided by 400. So on cancellation you get a is equal to minus 3.0625 meter per second square. This is all about your retardation, that is negative acceleration. Okay, so when the brakes are applied, the negative acceleration is minus 3.0625 meter per second square. So retardation of the car is found out. Secondly, it is to find out how long does it take for the car to stop. So the time taken for the car to stop, for that we will just consider s is equal to u plus at, because you have got your final velocity, initial velocity is there, acceleration you have found out. Now you have to find out t. So it is v is equal to u plus at. V is 0 because it's a car which is at the rest position, that is after applying brake it comes to stop. So it is 0. Initial velocity u is nothing but 35 plus acceleration is minus 3.062 into time you don't know. So t is equal to minus 35 divided by minus 3.062. You have got t is equal to 11.4 seconds. So on cancellation you get 11.4 seconds. So this is the time taken for the car to stop. That is, once the brake is applied, the car stop at time is equal to 11.4 seconds. So this is how you calculate by using the equation of motion. So you have to remember three equation of motion, which is very much important to you in case of derivation as well as in case of numericals. So the next sum is a player throws a ball upwards with an initial speed of 29.4 meter per second. So a ball is thrown upward by a player and the initial speed is set to be 29.4 meter per second. So this is your initial speed. So let us write given. So initial it is 29.4 meter per second. So first question is, what is the direction of acceleration during the upward motion of the ball? So ball is moving upwards. So a player who is present over here throws a ball upwards. So what is the direction of acceleration? They have asked you to find out the direction of acceleration during upward motion of the ball. So as you all know, the acceleration is due to gravity. Gravitational force is acting towards the center of the earth. This is earth and gravity is acting center of the earth, due to which whatever objects you throw up will come down. Right? So the gravity is acting towards the center of the earth. So there is change in velocity of the object when the object is thrown up. Therefore, you can say that there is acceleration, and acceleration that is due to gravity. So, acceleration always acts downwards, and here the acceleration of the ball is acting upwards. Acceleration due to gravity is always downwards, and downward motion is always a positive motion, and anything which is acting against the downward motion is said to be negative. So they have asked you the acceleration during upward motion of the ball. So they haven't asked you the acceleration of the ball. They have asked you acceleration during upward motion of the ball, that is said to be positive, that is downward. The acceleration during upward motion of the ball is acting downwards. So acceleration of the ball is said to be negative, but the acceleration here it is acting downwards. So the acceleration is acting downwards. Acceleration is acting downwards, where in the case of a ball. So during the upward motion of the ball, the acceleration is downwards. Acceleration of the ball is said to be negative of acceleration, minus a. Next is, what are the velocity and acceleration of the ball at the highest point of its motion? So when you just throw a ball, suddenly when you throw any ball or any object upwards, that is downwards to upwards, at a fraction of a second there is a pause and then it comes back. You just throw an object from down to up, at a point, highest point, it will pause and then it will come back. So that is what it is. So option B, that is your question B, says that velocity and acceleration of the ball at the highest point of its motion. So I told you it pauses. So when there is a pause, that is a ball or an object is at the state of rest. So when it is in state of rest, its velocity is 0 as well as its acceleration is 0 at the highest point. So you can term it as 0. What does your question number C tells? Choose the x is equal to 0 meter and t is equal to 0 seconds. Okay. To be the location and the time of the ball at its highest point. Yes, at its highest point, it doesn't seek any position nor any time taken for it to move. So it is 0 meter and 0 seconds. So vertically downwards, the direction to be positive direction of x-axis, and we have to give the signs of the position, velocity and acceleration of the ball during its upward motion as well as its downward motion. So we have to give the sign of position and velocity and acceleration of the ball during its upward as well as downward motion. So during upward motion, what is the velocity and acceleration of the ball? During upward motion, the velocity of the ball, velocity and acceleration of the ball is said to be negative, because therefore whatever acts downwards, there is a positive acceleration or positive velocity. Anything which is acting against this acceleration due to gravity g, which is having a value of 9.8 meter per second square, anything acting against this 9.8 meter per second square, then that is said to be negative. That is said to be negative. So upward motion of what? Upward motion of this object, that is ball, upward motion of the ball, that is against the acceleration due to gravity, it is against, that is why it is negative. So velocity is negative, that is the velocity decreases because the push is from up. So velocity decreases as well as acceleration also decreases, that is why there is negative velocity as well as acceleration. During downward motion, the velocity and acceleration of an object is said to be positive. So that is all about your question number C. That is third question number and option C. Next it is, to what height does the ball rise and after how long does the ball return to the player's hand? You have to find out the height as well as the time taken for the ball to reach back again to the player's hand. To what height does the ball rise and after how long does the ball return to the player's hand? So height as well as time is your work to be found out. So it is I have told you there are three equations of motion. V is equal to u plus at, S is equal to ut plus half at square, and v square is equal to u square plus 2as. These are the three equations of motion which is very much important for you. So now they have asked you the height. So I can consider this because I have got initial velocity previously in question itself, and my final velocity is set to be 0 because it is reaching player's hand. So once it reaches player's hand, the ball will be at rest, so it will be 0. You have to find out the height. So in this case, height is nothing but the vertical distance which is mentioned. So acceleration, it is 9.8. If it is not given, then you can consider the standard value of this acceleration due to gravity, that is 9.8 meter per second. So you need to find out S. So what is your V? V is equal to 0. What is your U? U is 29.4 meter per second. And acceleration A is 9.8 meter per second square, because acceleration is not given, so this is a standard unit. Then S is equal to, find out. So S also can be written as H. H is nothing but height, vertical distance, that is represented in H. So let me consider this formula, that is V square is equal to U square plus 2as. So V is 0 and this is 29.4 the whole square plus 2 into acceleration. You're throwing the ball upward, so it is acting against the acceleration due to gravity. So I can give it as minus 9.8, negative of the acceleration due to gravity, that is 9.8, and H. So H is equal to minus 864.36 divided by minus 19.6. So on cancellation, you're getting 44.1 meter. So your height, that is the vertical distance, is said to be 44.1 meter. So that is all about your height. Next it is, in order to find out time. Time to be found out. So in order to find out time, I will be using the first equation, that is V is equal to U plus AT. So you have got V is equal to U plus AT. So what is your V? Why V? V is equal to 0. That is the final velocity. So when a player catches the ball, the ball is in the state of rest. So it is 0, which is equal to U value, it is 29.4 plus what is A? It is minus 9.8 and you don't know the T. So T is equal to minus 29.4 divided by minus 9.8. You get it as T is equal to 3 seconds. So 3 seconds is sufficient for a player to throw the ball as well as catch it back. So that is all about your third numerical, and this is question number D. So this is all about the third numerical. Let us all meet in our next class. Until then, have a good day. Thank you.